Welcome to the webinar on automated GUI testing using froglogic Squish. Today we'll be focusing on testing hybrid applications or applications made up of more than one technology. For those of you not familiar with froglogic, we're headquartered in Hamburg, Germany, and are privately held. We were established in 2003 and have had steady revenue growth and been profitable since we were established. For anyone in the Americas, we've had U.S. presence since 2009, and we have a large and growing customer base throughout the world. The icons below represent some of the more than 3,000 companies currently using Squish. Now, before we dive into the product specifically, let's go over a few basics of automated GUI testing. Automated GUI testing is testing done at the graphical user interface level. UI regression testing, so regression testing your application at the interface level. It's there to help imitate user actions. You can run your tests unmanned, so executing them around the clock as part of your build process or as part of another process. And it provides a nice complement to manual testing, freeing up more time for manual testing or to create additional tests for your regression test suite. Why automate? It'll really help improve your quality and stability of your product, whether you're identifying issues faster because you're running tests around the clock, all with varying input. You're increasing your testing coverage. You're testing more in a lesser period of time or maybe more in the same period of time, and also testing additional scenarios that may not have been possible just performing manual testing, whether it was time constraints or just the intricate details involved in a data-driven test scenario, for example. Another thing that is increasing your testing coverage is the ability to test across multiple machines simultaneously. Now, as far as improving testing accuracy, you're helping to eliminate human error. Now, while human error can be good in some circumstances, it can also be good to eliminate human error when you're trying to make sure that your application hasn't regressed or moved backward from its prior release. Another thing commonly overlooked about automated testing and one of its benefits is the knowledge sharing that comes with automated GUI testing. The ability to share not only the results, but share how it was reproduced. Being able to share the execution of those different scenarios, as well as over time help to identify common areas of failure and how you might improve either the code in that area or improve your testing to make sure that you don't miss those critical areas. Now let's talk about Squish. So Squish is our automated GUI testing solution. It's cross-platform and works with multiple technologies. So we support a variety of technologies. You can see those logos represented on the left, and across the platforms on which those technologies are supported. For example, we're talking about hybrid applications today. We're talking about applications made up of more than one technology, more than one GUI toolkit. The example I'll show you today is a combination of a Qt application and web combined. Now, Qt is a cross-platform platform, and web is cross-platform as well as often cross-browser. Because of the way that we support each technology that's supported, in this case Qt and web combined or independently, those tests can then run across all the different platforms on which those technologies are supported without modifying your tests. Now, why Squish over other tools out there? Squish has dedicated knowledge of each of the GUI toolkits that it supports. This intricate knowledge is going to help you be able to work with not only controls across the different technologies that Squish supports, but also be able to work with your more complex or your custom controls. Hybrid application testing allows us to work with multiple GUI toolkits together from a single solution. And not to mention that we also share our source code with customers. Now, Squish also is going to provide you with powerful record and playback functionality as well as scripting. Now, our scripting languages we've chosen because they're non-proprietary and they're cross-platform, meaning your tests are going to work across the different platforms on which the technology you're testing is supported, and these scripting languages are real-world languages. We're not trying to limit you, but expand what you can do with your testing framework. We also provide record and playback functionality, and the scripting languages and the record and playback work hand in hand. When it comes to executing tests and distributing your testing across your testing framework, you're going to have the option to work with our different command line tools as well as the extensive set of integrations that we provide. Whether executing your tests as part of a batch process, as part of a build process, or by assigning the various tests as work items, each of the integrations provide a different way that you can interact with those tools natively as well as with Squish. The command line interface gives you the ability to either incorporate batch files, shell or bash scripts, or include those command line calls from your third-party application as well. Taking a look at a bird's eye view of the Squish architecture, you're able to create tests from the Squish IDE by simply clicking record, and behind the scenes the Squish runner is connecting via TCP/IP, whether that's local or to a remote machine, to the listening Squish server service, which is then injecting a hook in the application while launching it, allowing it to then report back the different actions that were recorded into a test script. Again, those test scripts are then created in the scripting language you've chosen to use: Python, Perl, JavaScript, TCL, or Ruby. When executing tests, it's a one-to-many relationship. Still from the IDE, or whether using the command line interface or one of our integrations, the test scripts will be taken in by the Squish runner, which connects again over TCP/IP, local or remote, to one or more listening Squish server services, which then launch the application, execute the tests, returning the results back to the Squish runner, which then outputs those results. At this time, we'll switch over to the Squish demonstration. From the Squish IDE, we'll begin by looking at the test suite I already have open, creating a new test, and clicking record. This launches our application under test, which happens to be made up of two different technologies, both native Qt and WebKit. It's an application, a hybrid application, and Squish can work with both of these technologies. As we interact with the application, everything is being recorded. The control bar indicates a status of the recording and also lets you select to create a verification point or stop or cancel the recording. If we create a verification point, we want to verify that the information submitted from the web form was extracted and placed into the regular or Qt controls. We'll select Create Verification Point, from which we can select the type of verification point we would like to create: screenshot, table, properties, or script-based. We can select the object on which we'd like to perform the verification point. And as you hover over the different objects, it will give you a cue of some of the information contained. Back in Squish, now that we've selected an object, we can see that object from the application objects tree instead of looking at the entire tree. We can also see any properties associated with that object and select which ones that we would like to verify. You can select one or more objects and one or more properties to verify. Clicking Insert, we're returned back to our recording, where I'll click Stop. We can now see the script that we recorded, and by clicking Run, we can see that script play back. One of the things that you'll notice in this application is after we click Submit, we're verifying that the display text Amanda appears in the field. However, the duration between when we click the Submit button and when that information is visible in the field can vary. So what we can do, instead of relying on it waiting for the object, which the object is there, it's present, it's visible, we also need to make sure that the information's been loaded before we begin verifying our verification point. To do that, I've created a simple script where I'm waiting for that particular object's text properties to be a length of greater than 1. Then, if that is a length of greater than 1, we will continue. If it's not, what it will do is log that it needed to wait for an additional 2 seconds before continuing. Now that only goes through the loop one time. It's sufficient for this application, but to further enhance this script, you could also iterate repeatedly through performing a few checks, and if on X number of checks the value is still not present, then send a failure. So there's different ways that you can enhance your scripts. You often start with a recorded linear script and then begin modifying it. Other ways that I've modified what was our original recording to this one that you're seeing right now is I've also included some variables, so that instead of entering in the text string each time, I'm now using these variables to enter in those different text strings, and below I'm using those variables again to verify the text property of the extracted field information matches the initial property. Now, how am I finding these objects? If we right-click on any of these symbolic names, you don't have to highlight it, I'm highlighting it just to point it out, we can right-click on any of those symbolic names and open that symbolic name. By opening that symbolic name, I'm able to see the entry for that symbolic name in my object map. Due to the recording resolution of the webinar, I'm adjusting things in my layout more than you would have to from your typical desktop, as you'll have a different resolution. So from here I have my object reference, the symbolic name, and below I have the real name, the collection of properties used to make this object unique when it's present. So what does Squish do when it's looking for these objects? It first makes sure the object exists. So it looks at these properties to make sure it exists, that it's visible, and that it's also enabled before proceeding in the script. So looking back here, we have a wait for object statement automatically built in as you record different actions. When you're manually scripting, you would incorporate this too. And the wait for object statement again uses that object's lookup to say, does the object exist? Is it visible? And is it enabled? All the criteria needed for a physical end user to interact with an object as well. Should that object not appear within 20,000 milliseconds or 20 seconds, an optional parameter which can be modified by providing an alternate value, then the script will time out, returning an error. 20 seconds is a long time for a user to wait for an object. Think about the patience of many of the users today, but it does give you that time frame. So if we run this script, we can also change the other script to include that check statement. And everything passed. Now that reminds me, okay, I have a script or a section of my script that many of the test cases throughout my test suite may want to reuse. How can I share that with all the other test cases in my test suite? I can do that by using this script and creating a test suite resource. I have one created called shared scripts. I can either create a new, or I can use this one and simply add a new definition to it. I happen to be using Python in this case for my test suite. So in this case, I called this particular function wait for extracted data load, and then I have everything that I had in my prior one. Because I'm waiting for the same field each time to make sure the text is there and the length is greater than 1, I don't need any parameters. If I had wanted to wait for a different field and check that, I could include this particular symbolic name instead as a variable and have it be a parameter for loading an object. Going back to our original test here now, we can, after clicking the submit button and before checking the properties or the verification point, what I'm going to do now is simply call this function. Now it needs to also know about the function. So we can use some of the code completion to see various functions available. So this is find file, the file type is scripts, and then the name of it, remember down below in our test suite resources, is called shared scripts.py. With that, I can now see any functions from this script. We'll click run and our test will execute. Now you'll notice when it executed, it logged the fact that it went into this function and it found that it needed to snooze. If I double click, that will take me to that called function and the corresponding line. And that allowed our main script to pass and wait appropriately for that object. Now, waiting for objects and waiting for things to load is not the only reason that you might modify your script. There's many other reasons. So let's say that you have a script that you'd like to have run based on a set of data. Perhaps you have a spreadsheet, a database, anything with data in it, and you'd like to use that information to run your script. This example right here shows loading a TSV file and using that file to execute through a similar script that we recorded the first time. Remember, here's our length, our wait fors to check the information, adding the information here, passing in the variables. But this time, what it's using is this test data that I've created. Now we support spreadsheets, TSV, CSV files, databases, etc. But using this data, I can now run the script. I did put a limit of 5 in there so that you don't have to watch this over and over beyond 5 times. Now that the script finished executing, we can take a look, and you can see for each iteration the various information, the verification points, the information that was compared. Another thing that you're able to do, each of these verification points are passing. What you can also do is if something fails, you can capture it on pass as well, or if you'd like to take a screenshot at any point, you can do it on pass, fail, error, or simply on demand to take a screenshot to have a visual in addition to any information that you're collecting for your report. Now let's take a look at what happens when a test can't find an object. So remember, this verification point failed, but it could still find the object. What happens if it can't find this object? Let's take a look at the object map entry again. Looking at our object map entries, you can see again the object's symbolic name and real name. These can be dynamic, any of the values, by incorporating a wildcard or regular expression so that in the event a portion of this object's reference changes or any of these values, you can keep up with those changes. You also have the ability to use a real name directly within a script and then provide variables to help fill those parameters at runtime when you don't know all of the values of the object ahead of time. What we're going to do here is we have this submit button, and I'm going to change the value to submits. Squish isn't going to be able to find this particular object based on this value, as we're looking for that exact string equals. Well, let's run our test and see what happens. So now it's looking for that button. Remember the 20,000 milliseconds or 20 seconds in order to find an object, should it not be visible or enabled at the time the error occurs? Well, this is what happens. We have our object not found. The object not found dialog is showing us the error that would have appeared in the script had it been run unmanned or had you not been using this feature from the IDE. It's showing us the value that it's looking for and gives us the opportunity to throw an error, debug, or retry. First, let's go out and pick the object that we're interested in. this submit button. Now notice the last time I used the object picker I was interacting with a native Qt object. Now I'm interacting with a web object. We're able to interact between these two different object types or sets of toolkits from a single tool from Squish without an issue. So here we're able to see the difference. If we click retry, we can see if that resolves the issue. If you're not certain, you can always debug, throw an error, and if it doesn't work, it will return to this window. Because it worked, it finished executing the test, and now in our object map, that object map entry has been updated. Had it not worked, it would not have updated the object map entry and would have returned you back to the object not found dialog where you'd have the opportunity to debug the test, throw an error, etc. Now other ways to reach the test debugger: simply set a breakpoint and run to that line. From there you can also record a snippet, or you can record a snippet from any line in your script. We don't have time during the webinar today to go over all the different ways you can record a snippet, but there are some videos out in our video library as well as our documentation and knowledge base that talk more about working with and recording snippets. Let's run to this breakpoint. And from the breakpoint here, we can see where we are in the script. If we had any variables in our script, they would appear here as well as their values. We can navigate various objects either manually through the tree or using the pick tool, much as we did when we were creating the verification point, as well as working with the object not found dialog. When you're manually scripting, at times you may want to validate syntax or simply see what the anticipated output is of a particular command. You can use the Squish script console to do actions like that. There's also a video in the video library which talks more about the Squish script console. I can now continue by stepping through my script or recording new steps by recording a snippet at any point in this debugger. I can also then resume the execution. Now everything that I've been doing so far has been from the IDE. Once you begin developing your test framework, you'll want to execute these tests, whether you're executing them using our command line interface or using one of our many integrations. Tests that you execute, this happens to be a cross-platform application, can then be executed across all the different platforms on which that application is supported without modifying your test script. To execute a test using the command line interface, we first need the Squish server listening on either our local machine or wherever we would like this test to execute. I have a very simple batch file here in which it's moving to the directory where the Squish server is located and simply starting the Squish server. Should I want to start it on an alternate port, I can simply provide the port parameter and which port I would like it to execute on. If I don't specify a port, as you can see from here, it will execute on port 4322 or the next available port. With the Squish server listening, I can now use our command line interface or one of our many integrations. I'm going to use the command line interface here today and execute the test against this local machine. Again, I have a batch file simply to help show what the different steps are if you were to use the command line interface and how I happen to have approached it. You'll notice things in Squish, they're very flexible. There's always multiple approaches to how you may work with your tests or distribute your tests. Here I happen to have a Squish path. So what is the path to my Squish package? The test suite that I'd like to execute, where I'd like the reports. So I set those variables up, as well as the Squish server I'd like to execute against, the port that it's listening on, and I'm using a Python path as a variable also so that I can use the Squish XML to HTML Python script following my report being outputted in XML so that it will convert it to HTML. So here's our Squish runner line. This is the line doing the actual call for the execution. And we can see here the various variables being called for the remote execution. Now the reason you see it commented out here is because I demonstrate this often against other boxes as well, showing how the same tests can run against the multiple machines. So now we'll run the batch file. Move this over here so it's a bit out of the way so that you can see the test executing. Remember, I'm executing this all within one local environment, but this can be executed and distributed across your different machines by simply specifying the host and host port that you'd like to execute this on. It's executing the entire test suite, including that test that we made during the webinar. And after all the tests execute, remember I converted the XML to HTML right there within that script, and you can see the different scripts that have run, the execution report history, and if we look at the last one, which is ours, we can see all of the information that was available from the IDE is now logged in a nice HTML report. Had I captured any screenshots, those would appear here as well with a link to the corresponding screenshot. So all of that information is then available from your report. When you're working with an integration, many times the report appears directly within that integration in the format for the particular tool that you are using. Thank you for attending this webinar on working with hybrid applications or applications made up of more than one technology using Squish GUI Tester. Download an evaluation at froglogic.com/evaluate and see our other resources at froglogic.com/resources.